Okay, so today we're going to be starting our first section of chapter 6, which is 6.1. And we're going to be solving systems by graphing. So hopefully by the end of this section you can say that I can solve a system of equations by graphing and I can analyze special systems of equations. So first of all, systems of equations are simply two or more equations working together. A solution to a system is an ordered pair that makes the system true. So if I were to look at this system and I were to plug the solution, which is 5, 3, back into those two equations, 5 times, or excuse me, 2 times a 5 plus 3 does give me 13, and a negative 6 times a 5 plus 4 times a 3 does equal a negative 18. Okay, so it works for both of them, so we say that is a solution to the system. So to solve a system by graphing, you're going to have two equations. You're just going to simply graph each one. So the first one, the slope is a 1, the y-intercept is a 2, so I start out at a 2, and a slope of 1 means I go up 1 and over 1. Okay, so I end up with this line. The second equation has a slope of a 3, a y-intercept of a negative 2, so I start at a negative 2, I go up 3, I go over 1. So I end up with this line. So what do we notice? We should notice that they intersect at this point, which is 0.24. So we consider that point, the significance of that point is the solution. The solution is 2, 4. And how do I know it's a solution? Well, I could put it back in. 4 is equal to 2 plus 2 if I'm putting it back into this original up here. And 4 is also equal to 3 times 2 minus 2. So I do get the solution of 2, 4. So if I were to look at this one and I graph this one, again, on the first one, my slope is negative 3, my y-intercept is a 2. So I start at 2, and I go down 3, I go over 1. So I have this line here. If I look at the second equation, I've got a slope of a 2, a y-intercept of a negative 3. So I'd start at a negative 3 and I'd go up 2 over 1. And again, I'd find that they intersect at the point 1, negative 1. Okay, so if I were to look at this one, if I were to graph the first one, slope again is 1/2. The y-intercept is negative 6. So I'd start at a negative 6, and I'd go up 1 and I'd go over 2. Okay, the second equation, if I solve for y to graph this one, I'd have 2y is equal to 4 plus an x. And if you divide by 2, you get y is equal to 2 plus a 1/2 x. So I start at 2, I go up 1 over 2. And what we should notice that those two lines are parallel. Okay, if the lines are parallel, we say that there is no solution because the lines never intersect. Okay, next one. If I were to graph this one, the slope of this one is negative 2/3. The y-intercept is a 6. So I start at 6, slope of 2/3. I go down 2 over 3, down 2 over 3. I got this line. If I solve this one for a y, I minus the 2x. I'd have 3y is equal to an 18 minus 2x. Divide by the 3 and you'd have y is equal to 6 minus 2/3 x. So I'd have a 6, 2/3 x negative. I go down 2 over 3. And what we should notice in this case, it is the same line. So it's the same line. So how many solutions are there? We'd say that there's infinitely many solutions. And we say that the lines coincide. Okay. So some things that are possible. First of all, you could possibly have one solution. If there's one solution, the lines are going to have different slopes, and we say that the equations are consistent and independent. Second one, the lines are the same. The lines have the same slope and the same y-intercept, And the equations are said to be consistent and dependent. If we look at the second one, the lines are parallel. The lines have the same slope, different y-intercepts, and the equations are said to be inconsistent. Okay, the other place that you may see equations used with graphing is when we have story problems. So it says scientists studied the weights of 2 alligators over the period of 12 months. The initial weight and growth rate of each alligator is shown below. After how many months did the alligators weigh the same amount? So if I look at this one, I would say that the time is x, weight is y. So I would have something like this. Alligator 1. The weight of that alligator started at 4, and it grows at 1.5 every month, so the equation would be 1.5x. The equation of the second one. The weight starts out at 6 plus 1 pound every month, so it would be 1 or 6 plus 1x. So if I were to look at the graph, first thing you got to have time down here in months. And here you'd have your weight, and that weight is in pounds. And we have 1, 2, 3, 4, 5, 6, 7, 8 months. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. Pounds. So if I were to graph this first one, started at 4 pounds, and I grew 1.5 pounds every month. So I'd be going up 1.5 pounds every month. Okay, 1.5 pounds. Made a mistake here. 1.5 pounds, 1.5 pounds, 1.5 pounds, 1.5 pounds, 1.5 pounds. Okay, so I got this line right here. Second one, we know we started at 6, and now it's only growing 1 pound every month. So where do they intersect? They intersect at 4 months. We know that they're both going to be 10 pounds. Okay, so hopefully we can see where we can use graphing to solve systems and how we can apply them to some story problems. So that is a wrap. Have a great day.